Hi guys, this is what my three-phase transformer looks like. Currently I've got it hooked up so the two secondaries are in series, and I've got a 1 ohm resistor in series with the primary, which you can see here. I'm just monitoring the current. I get 1 volt per amp across the series resistor there into the primary, and across the output I've got this little plug pack monitor so that I can monitor the output. And you can see we're getting about 242 volts out. And across here, we're just running it off a little inverter at the moment, which is pure sine 600 watt, but it's only a Chinese thing, so it's probably not really 600 watt. And just looking at the display there on that little plug pack, I don't know if you can get that. Can't get a good. Geez. Here we go. That's about 890 milliamps, 63 watts, 240 volts, and that's just going across into the three-phase transformer. It's pretty not very reactive, this transformer. It has not too much inductance in the windings, and if it had any more inductance, probably this little inverter wouldn't even run it. So this is what the display looks like on a scope. All that noise is from a battery charger. I'm running it off some supercapacitors, the inverter, and across the supercapacitors I have a battery charger running, which is here. I'll just turn the battery charger off, it'll get rid of some of the noise. And there we are, that's the, even now it's pretty noisy. The oscilloscopes, I've got it set to 20 megahertz bandwidth, but it's seeing a lot of the switch mode noise out of the inverter. So I'll just turn it off for a sec, pause it, and I'll show you what it's like straight off 240 volts. Okay, back again. This is just running off the mains, which is unplugged it from the inverter here. Unplugged it from the inverter, and now she's running just straight on the mains power point, and you can see about 15 watts, 245 volts at about 93 milliamps. If I turn the load on while we're watching the oscilloscope display, the yellow traces the current and the red traces the voltage. And I'll put a load on, which is, now it's loaded with a 60 watt light bulb at the output of the three-phase transformer, and we can see that there's very little phase shift in its unmodified state, and there's probably not enough windings to maintain any sort of phase shift under load, but the magnetic shunts to go across the top and bottom should remedy that phase shift when you switch from on load to off load. You can see there's maybe 0.8, 0.9 of a division in 360 degrees, which works out, well actually I should work it out again, but I think it's about 46 degree phase shift. I had less than that before, but I found another tapping I could use on the transformer which gave me a bit more inductance, but still there's not enough there, and it needs to have windings, the windings increased on those three coils in order to get a bit more inductance. Thank you guys. Bye.